So our objective tonight is I can rewrite expressions in different forms to shed light on a problem. And what New York State, I believe, what their true objective was they wanted to take your expressions equations unit and relate it back to our percent unit and to our ratio and proportion unit. So that's kind of my goal here, is to take a look at, in terms of expressions and equations, like how can we take what we've learned all year long and apply it to these situations? So that's what I'm trying to do here. Let's jump right in. Kevin's savings account had X dollars at the beginning of the month. At the end of the month, there was 4% more money in Kevin's account. Which expression represents the number of dollars in Kevin's account at the end of the month? Well, as soon as I say, oh, they're talking about 4% more money in Kevin's account, I'm like, this must be a percent increase problem. But now they're not giving me a dollar amount at the beginning of the month. They're just telling me there was X dollars at the beginning of the month, and they want to know the amount of dollars at the end of the month. So this is a percent increase problem. And so what I would write down is the formula that we used when we did our percent units for percent increase. All right. So what was the original amount that Kevin had? His original amount is the beginning of the month. So the beginning of the month would be the original amount. And then we're going to have to tack on additional money. And at the end of the month, we're going to get the new amount. So our original amount here is X. And we have to say, okay, by what percentage did the money increase so that I can get my total at the end of the month? So at the beginning of the month, originally you were paying 100%. What percent do we need to tack on? How much more are we making? Oh, we're making 4% more. So by the end of the month, there's actually 104% of your original money in that account. But we know in our percent equation, we have to take that 104% and rewrite it as a fraction or a decimal. So we have to take 104% is always out of 100. If you divide that out, you get 1.04. So that is your percent written as a decimal. And that's what we need to use in the equation. So this is 1.04. That's going to give us our new amount. And again, now it would be any amount of money. Let's say they said there was $30 in the account at the beginning of the month. You can multiply by 1.04, find out how much at the end of the month. And a lot of times, like as you go further in life, they want to come up with one expression or equation that you can use that we can substitute any value in. So that's how this works. So this is the correct answer. They put this answer in because that would represent the amount to tack on, but not the overall total. And they want to know how much is in his account total at the end of the month. This would be like you take your original amount and you tack on 4 cents. Well, no, 4% is going to be 4 cents on every dollar. So you're going to get a lot more than 4 cents in that account. This would be your beginning amount and you get $1.04 added on. And they want a percentage tacked on, and so we fall back on our percent equation. So let's try another one. They usually on the state test, they bring percents in quite a bit, and then they'll also bring in like the cost of items. All right. Sally has a discount card that reduces the price of her grocery bill in a certain grocery store by 5%. So this is a 5% reduction. If C represents the cost of her groceries, which expression represents her grocery bill? Okay, now that it's a reduction, it's a percent decrease problem. So again, I just write down my new equals percent times my original. And I look at her original. What was her original amount? Oh, good. The original amount she paid was C. We're going to multiply that by some percentage. So her original amount was C. We're going to take off a certain amount, and then we'll come up with the new. All right. So if I just look at it in terms of percentages, what percent was she originally paying? Oh, you go to the grocery store, you got to pay 100%. But she has this beautiful 5% reduction. So she gets to take off 5% of her bill. How much is she still paying? Oh, she's still paying 95%. So then you just take that percentage, write it as a decimal, and then that is what you would use in your percent equation. So the new value is 0.95 times the original. They always put this in as a possibility because that just shows the amount you're reduced by, but it doesn't give the overall new grocery bill. That would be like you only still have to pay 5%. No, they still expect you to pay 95%. This one right here is like she gets 5 cents off her grocery bill. Nobody's going to go through the hassle of getting these discount cards if you spend $100 and they only take 5 cents off. That wouldn't be very helpful. And here, this would say the discount card, no matter how much she spends, they're going to just tack on an extra 95 cents for fun. I mean, that would just be silly. I could eliminate that one. All right, let's take a look at another. This was from the New York State 2016 assessment. And this really, when I first looked at this problem, I thought this really ramped it up for my 7th graders. But then I really broke it down. I said, okay, my 7th graders could handle this. And I'm going to actually, as we go through this problem, talk about one strategy for eliminating some of the choices. When you take a multiple choice test, sometimes it's helpful to eliminate choices that don't have a shot. So let's go ahead and we're going to do that strategy along with solving this, solving this example. Oh gosh, so sorry. Okay, Lance bought N notebooks that cost 75 cents each. All right, we know he bought N notebooks that cost 75 cents each. So what you do to figure out how much he spent in notebooks, that would be 0.75 times N. That would be the cost in notebooks. That's how much money he would spend on notebooks. And P pens that cost 55 cents each. So to figure out the cost of your pens, you take the cost of one pen and you just multiply it by the number of pens you buy. A 6.25% sales tax was applied to the total. Okay, so this is a sales tax problem. All right, so we know sales tax you have to add on your sales tax. But again, it's a percentage, 6.25% is going to be added on. Which expression represents the total he paid including tax? So for the total, it would be your cost for your notebooks and the cost for your pens. Maybe that would be our original. And then we're going to tack on a certain amount of tax. So you got to take your original and tack on the amount of tax you got to add on. Okay. If I look at this problem, so wow, there's a lot going on here. We have N's and P's. Well, at least we have N's and P's. N's and P's. At least we have N's and P's. I feel good about that. Letter B has some N's and some P's. That feels good. Letter C only has, only has N's. Well, we know we have to deal with the cost of pens. They want the total he spent, not just the amount he spent on notebooks. So I'm like, well, at least that's not a possibility. Then I look at this expression. I'm like, oh, God. This only has N's again. I have to incorporate my pens to figure out my total. So at least I'm like, okay, thankfully it's not either of those. So now I look back here. If I take 6.25% of the number I buy and tack on 6.25%, I don't know. Let's take a look. And this one would be if I took my cost of my notebooks and my pens and I added on the tax. Well, I feel pretty good about letter B, but let's talk about why. So this one might be, I'm trying to decide the best way to handle this. You know what? I think I'll handle it the way we normally would and then take a look back and relate it back. So let's just take a look. If we had our method, we would do new equals percent times original. I'm just going to stick with the method that we use throughout our percent or percent unit, and then I'm going to relate it back to this. All right, so we know originally you paid 100%, and then you're going to tack on 6.25%. So we're going to pay 106.25%. I'm going to rewrite that as a decimal, 106.25 as a decimal. If I divide by 100, would be 1.0625. Okay, I like that. And then my original, what was my original cost? Oh, I wrote it up here. The original is actually your cost of your notebooks plus your cost of your pens. All right, I have my overall percentage. I'm going to jump up by 106.25%. So my new price will be 1.0625 times the original amount I spent. Well, the original amount I spent was 75 cents for each notebook plus 55 cents for each pen. Then I look here and I say, gosh, if only one of these became this. Let's see if we can make one of those become this. Let's take a look. The coefficient out in front of here is a 1. And I have times this. That looks familiar. And then I have this 0.0625 times this matching item. Oh, that looks familiar. So if I tacked these together, what's 1 plus 0.0625? Wow, letter B would become 1.0625 times what's in these parentheses, 0.75n or 0.75n plus 0.55p. It's actually letter B. You take the original you're going to pay and then you tack on 6.25% of that original. I think that's a pretty intense problem. But that's what they would expect you to handle on the state test. And I believe now that we know how to handle these problems, we'll just keep practicing this for the rest of the school year. All right, let's just see. Let's do one more, and it's too bad I haven't spent a whole lot of time relating it back to the ratio and proportion unit, and I really wanted to be able to, but I'm not going to have time tonight, I don't think. All right, let's see. The original selling price of a stock was $D. The selling price for a share of the stock at a later date was represented by 1.15 times 0.95D. Which description explains what happened? Okay, so I would start within my parentheses. 0.95D, D is your dollars. 0.95D would be a 5% reduction, right? If you're still paying 95%, that means a 5% reduction. After that 5% reduction, now it's 1.15. Oh, hopefully we're starting to see 1.15. What percent increase happened then? Oh, that's a 15% increase. So that's how we would pull these apart. If you're still paying 95%, that's a 5% reduction. But after that reduction, something happened where it bumped up the stock price, and it bumped it up by how much? An extra 15%. The price decreased 5, then increased. Okay, they're going to put these in because if you accidentally leave a percent sign attached to your decimal, so I already know those don't have a shot. A and B didn't have a shot. The price decreased by 5%, then increased by 15. That looks pretty good. The price decreased by 95%. No way. You're still paying 95%. It's absolutely letter C. And I won't have time to relate this back to ratios and proportions, but hopefully you can do that. All right. Hopefully that helped. Have a good night.